UT or VR. I cannot use those because I just don't know anything about them. It's only focusing on the median of SW. So now let's change gears and look at an altitude. The altitude of a triangle is a perpendicular segment vertex to the opposite side, or a side that contains the side. Now we're going to look at what that means in a second, but just looking at our first triangle up here. If I had this triangle, maybe I'm thinking of it as like a mountain, and I want to know what the altitude would be if I'm standing at the top of the mountain. I would measure the perpendicular line to the top. That's going to be my altitude. Now, this triangle, which is obtuse, it's still going to have a perpendicular distance, but now it just happens to be outside the triangle. Nothing wrong with that. This side is still contained on this. You just kind of extend it out, and that gives you my height. Now, keep this in mind. Obtuse triangles, altitudes will likely be on the outside. So, let's work our way to this. So, concurrency of altitudes of a triangle, and tells us the lines containing the altitudes of a triangle are congruent. Same with the medians. If the lines will intersect at a point. On this one, we have an obtuse triangle for ABC. This is the point they all have in common. And again, it's outside, and that's fine, as long as we're connecting the perpendiculars. Notice we've extended this side AB to get the perpendicular. We've extended the side CE or AC to get that perpendicular, but they all exist. We'll look at an example with all of them in a second. But before we do that, when we talk about where the altitudes meet, it's the place we go to get our braces, and that's the orthocenter. So the altitudes meet at the orthocenter. We had medians meet at a centroid, altitudes will meet at the orthocenter. So let's work our way through and sketch a couple of them, acute, right, and obtuse triangles. And usually when we have that side on the bottom, the base is pretty easy to first find that first perpendicular. We go to our next one here, we're looking for another perpendicular. And if we have two, the third should go through the same point, and it will if we do it correctly. We got our perpendiculars, or altitudes I should say, and they all meet at our orthocenter. And this one happens to be inside the triangle. And that'll be the case on all acute triangles. If I look at a right triangle, now the height, the altitude of this triangle is this outside side. So this line, I'll kind of highlight it here, see if we can. It's right there, and it goes to that part. This side, if we almost turned our paper, and this side, if we marked it down, well, that's still the outside side. So that's also where it meets. So far, the two of them meet right there at the vertex for a right angle. If we take our other one, other side, would be the hypotenuse in this case. Connect it. There's our altitude. It would also go through, and in this case, if it's a right triangle, we'll actually find that the orthocenter is on the triangle, and it's the vertex of the right angle. Now lastly is obtuse, and we've kind of previewed obtuse already. If I draw down my altitude, there's one perpendicular. We need to fix that line there. Alright, maybe it's a little harder to find the whiteout as planned, but we gotta clean it up a little bit here. Line got off a ways. Just because I'm rummaging through whiteout does not mean it's time to go check Facebook. No one's updated their status yet. But if we extend it down here, we have our first altitude, our second altitude extend, and we get to that point. We're going to be careful here. I got a little white out, so we don't want to get too much into it. But this third one, we're going to extend it. And our perpendicular comes down, and we see that they do meet at this point, and that is our orthocenter. It's perfectly fine that it's outside the triangle. In fact, it will be for an obtuse. Acute, inside, right on the triangle, at the vertex with the right angle, and an obtuse will be on the outside. So, for altitude, really all we know. Altitude is a perpendicular line that goes through the opposite vertex, and it meets at an orthocenter. We're not really going to see too many problems where we need to solve the values with them. So let's look at a couple examples. One goes back to our centroid, and one is kind of putting them all together for the ones we've already looked at in the past few sections. But if we look first at our centroid, we need to find the coordinates for it. So we start off, we have A. Let's mark C. And we have B. Now, I need to find where that centroid is. It's somewhere in here. We could go through, find the midpoint for all of them. Once we found the midpoint, connect them, find the centroid. Once we find the centroid, we could even take that 2/3 idea and start working through it. But we don't want to do that. We want to use as easy as possible and kind of manipulate this graph as much as we can. The same idea where we kind of used coordinate proof earlier in this chapter to get to our answer. Well, let's think. What's the easiest segment to find the midpoint of? No? No? Hey, how about BC? BC looks good because I know the height from B to C is 8 units. Well, half of 8 is 4. There's my midpoint. That means here's my median. That's one of my medians already if I have my midpoint. Now, let's look at the length of my median. So from A to that opposite side is 6 units. So we know that from A to that other side is 6 units. There'll be some centroid somewhere that breaks it up. We don't know where yet. That I have 4 and 2. And that's my 1/3, 2/3 rule. Well, let's use that idea. Maybe that even helps give us an idea. If it was there, it would be 4 units from A, 2 units from the side. If it was there, it would be 2 units from A, 4 units from the side. Now, if you already know the answer, because we remember how far it needs to be from the vertex, if it's the longer or shorter, you kind of see where it's going. But let's take a second here and look. It's either here or here. Well, if we're not sure, if we knew another median, we know where it's going. Well, if I look at A to B, A goes up 4 units. Up 4 to get to B. So I'm only going to go up 2. A goes over 6 units to get to B. I'm only going to go 3, and actually I find, there's another midpoint. I connect them. There's another median. So in fact, my centroid is right here. My coordinates for that will be 3, 2. It turns out it's 4 units from the vertex, 2 units from the side. Gives me a total of 6. So my coordinates for the centroid are 3, 2. Okay, last we want to look at identifying if we have a perpendicular bisector, an angle bisector, a median, or an altitude. Now, what we get from this information is telling us what we have. A median, we need a midpoint. Altitude, we need perpendicular. Angle bisector, we need congruent angles, angles bisected, or perpendicular bisector is really the combination of a median and an altitude. So you really want to combine the two. If I look at my first one, I have a perpendicular, and that's it. Since that's all I have, I know for sure it's an altitude. Because again, it measures the height of my triangle. It's not a midpoint, so it's not a perpendicular bisector. There's nothing about the angle. It's not an angle bisector. There's nothing about the median or a midpoint, so I can't use that. So it's just an altitude. Second one, XW, ZW. Those are congruent. Means I have a midpoint. Midpoint means I have a median. So that's good. I do not know if it's perpendicular, so that's out. It's not an altitude, again, no perpendicular. I do not know about the angles, so that one's out as well. If I knew some more, maybe I could, but we don't know enough information here. Okay, last one we have the two triangles are actually congruent. Well, this one actually makes it nice for us because I have perpendicular here. Those are congruent angles. So is those sides. Got some angles out here, angles up here. We got reflexive for YW. If we mark them all out, we kind of check through and see they all work. Perpendicular bisector. That works. W is XZ is perpendicular to YW, perpendicular. It's also a midpoint, so perpendicular bisector. It bisects this angle at Y, so that works for angle bisector. Median, well, I already said that's my midpoint. Altitude, I already said it's perpendicular. It works for all four. You won't see it too often. We have to have certain things in place, but really when the two triangles match, they're all going to work. So I hope that helped. Now get to work on your homework.